we would like to show you the principles of price formulas. Price formulas are a major building block of the K method. Before getting to price formulas, we would like to map buying commodities according to the expenditure and specification. I apologize for adding another mapping type to the long list of possibilities how to map buying commodities, but this one serves our purpose the best. In the bottom right corner, we find true commodities, which typically have a high expenditure. This segment is the leverage segment. The market price is driven by demand and supply, and when these two forces are balanced, the prices normally reflect the lowest acceptable margin for suppliers. This segment also reflects somehow that the full capacity of suppliers is used. Hence, when talking about natural commodities like sugar or palm oil, the supply volumes may be volatile, subject to harvests, and therefore also the prices may be volatile. If the market mechanics are not manipulated on the seller side by cartels like the OPEC for crude oil, these markets are quite convenient from the buyer's point of view. Very often, business is done via marketplaces where the buyer can select various suppliers. At those marketplaces, market price transparency prevents buyers to pay irrational premiums. Specifications of those commodities are very often standardized by public organizations like the European Union. Even if in the public opinion it seems to be ridiculous to define the maximum bending angle of cucumbers to qualify for a trade class, these elaborate public specifications allow buyers to buy arm's length from suppliers without prior inspecting the merchandise or even meeting the supplier. Looking at the lower end of expenditure for commodities with public specifications, we find the so-called C materials. Pure purchasing expenditure is so low that the full cost of the procurement process also kicks in as a relevant factor. Strictly speaking, some of the goods don't fall under a public specification, like pens, as there are hundreds of different pens which mainly differentiate themselves in their design. But such distinguishing features are often ignored by buyers who rather look on color and reasonable handling. On the other hand, we see specifications which are the intellectual property of the supplier. Those are goods which carry to a certain extent supplier-exclusive innovations. This could be, for example, a special chemical which, when added to a detergent, improves its washing performance. Hence, this innovation may qualify as a feature for the client. For the K method, this will be an FMCG company, will use for his final product. The price of such a material will be strongly linked to the value it delivers for his client rather to its own production cost. This means normally very high margins for the supplier. In the middle segment of the chart, we see materials which are custom made for the client. This means that the specification is owned by the client. This means also that exact these materials can only be used by the particular client and by no other company. The materials of this group are produced by commodity technology, so there are various suppliers to select from. Examples of categories falling into this box are nearly all categories of packaging materials, such as labels, folding cartons, and tubes. While the categories in this segment are considered as true commodities, they are not treated as such. Due to the high number of different specifications and different prices, there is no true price transparency. Each material item of a category is negotiated individually, while the leverage effect of the total volume of that category can't really be reconciled from the prices. Hence, it is the aim of the buyer to move these categories to true commodity box to take full advantage of leverage and price transparency. This is easier said than done. When we look at supplier-client relationships, of the different segments, we see something remarkable but not surprising. While the segment of C materials and true commodities has on its playing field several suppliers serving several clients with the same specification, we see in the segment with the supply and innovation just one supplier supplying the market. In an extreme case, this market may only be one client if that client was able to secure this innovation exclusively for himself. However, the segment of custom-made materials will always have only one client for a certain specification, since the specification is owned by the client. This triggers automatically some constraints in production and supply chain of the material. Since there are no alternative clients to buy that material, caution has to be taken on the supply side not to produce too much stock. In the world of packaging materials, with the high frequency of changes of specifications, it is advisable for the supplier only to produce so much stock as the client explicitly has committed himself for. Typically, this means short production runs for the supplier, as clients tend to commit themselves only for short periods. Hence, the aspect of machine setups with the supplier kicks in very strongly when sourcing packaging materials. Currently, many pricing terms between suppliers and client have an element of this. Sometimes a setup fee is separately charged to the client whenever the client places a call-off. When we have a look at the production scheduling of a supplier for the different products of the client, the picture may look like this. We see for the machine number 1 a setup for product number 1, which is then followed by the actual production run. This client is using for his products 3 of the 4 available production machines of the supplier. In most cases, this is the decision of the supplier which machine he uses, and at a different time period also machine number 3 may be used for the client's products. When we change the view and just look at the production blocks which we arrange like this, we could also look at the call-off volume of the client from a time point of view, where the length of a block represents time. Just to fresh up, the client has different specifications which may lead to different setup times for a machine and different production times once the machine is prepared for production. It would now be a great idea to agree a function with the supplier how different specifications translate to different setup times and different production times. We are sure the supplier is able to provide such a formula, as he knows his machines very well and needs to make certain assumptions for his own cost calculation, which is the basis for his commercial offer. So once such a formula is agreed with the supplier, it is all about price per time unit. Probably you will need 2 different prices, one for the price per hour of machine setup and one for the price per hour for the actual production run. Our original target was to transfer buying categories like labels to the segment of true commodities. Once a formula has agreed with the supplier how to translate label specifications to setup and production times, the buyer can now recalculate his annual portfolio to setup and production hours using his formula. In the next step, he could go to the market and try to procure the required hours. Hence, setup respective production hours become a true commodity for a buying category like labels. In such a case, price transparency can be achieved, and probably the total cost of sourcing labels will drop, as the buyer can use his full leverage on all of his labels he sources using a single price. The bad news of this method is that it will work for some buying categories, for most it will not. The reason is that the formula to translate specifications to time units is too specific to the machine park of a certain supplier. Another supplier with much bigger machines may ask a much higher price per hour, but will produce more labels in that time. Hence, buying machine hours only makes sense when all suppliers in a supply market have more or less the same machine setup in their factories. Now the good news. We'll not be able to squeeze all labels into two prices which represent the cost of an hour of machine setup and an hour of production. But the idea is not lost. What about pricing specification features like size, print technology, number of colors directly? This would mean that we have two prices for each feature. This might not be as handy as two prices in total, but if we end up with 40 different prices for a buying category, this is still a major achievement. Please remember that big FMCG corporations may have a couple of thousand prices in a buying category, like labels, and just needing to deal and negotiate 40 is certainly an improvement. And here's an example how it looks when it is implemented. This is an example for labels, which in fact has been implemented for a client exactly as you can see it. Just the prices have been modified for this demo. In the upper left box, you see the different specification features like the dimensions of the label and the print technology required. This price formula is designed to use two different technologies for a label, so offset and silkscreen printing can be combined on one label. In the upper right box of the price formula, you find the structure of the pricing of individual features. So there are three columns representing the different print technologies, and the prices are split between setup, changeover, and run. The changeover is actually a small setup which allows taking advantage of printing labels in a certain sequence. In such a case, not every label requires an entire new setup of the printing machine. In the lower right box, you see a list of feedstock materials which can be specified by the client. The prices are not the cost of the supplier, but the price he offers to the client. So these prices will include handling and reasonable profit markup. In the bottom left box, you finally find the specific price for a call-off. The price is split between setup and run. You can see if you play with the volume of the call-off or some parameters of the specification, the price will automatically change. So we change this 100,000 to 50,000 volume, and you will see how the price changes. And we change the number of colors here to 8, and again the price changes. To wrap up, price formulas are not a single price like it would be expected for true commodities, but something quite close. The beauty is that the buyer can collect easily price quotations from different suppliers and receive full market transparency, while the pleasure is only on his side, as suppliers don't improve their level of market information. But most important is that the buyer can leverage his full portfolio, as the supplier will only provide prices in a certain volume context, which is probably measured in money or square meters, and not in time as afore proposed. Having full price transparency of the market and leveraging the volume was the target in order to buy packaging materials like true commodities. Price formulas, being a part of the K method, will do this for you.